Okay, question 9. We've got an exponential modeling question. Vertical speed of a skydiver. Always a good idea to try to interpret what's going on here. We've got a negative exponential, which is an exponential decay, and translated up by a. So this is some sort of function. Don't have to do this, but what's happening here is we've got an exponential decay, which is coming down towards this value. Normally it would come down towards 0, but it's going to be coming down towards a. Okay, and the b value is not the y-intercept, but the y-intercept is a plus b, isn't it? Because if t equals 0, it's coming through there. So we're starting off at this value and we're decaying down towards a. So that's kind of what's going on here. So nice to sort of have some sort of understanding of what's going on. Right, question A, we're given 2 data points and we've got to work out the values of A and B. So V is A plus B e to the negative 0.5t. We know that if t equals 0, which is the instant it opens, V equals 56. So that means 56 is A plus B e to the 0. Don't forget e to the 0 is not 0, it's 1. So that is A plus B. The second data point is t equals 5. Always check units. 5 seconds, and it is t seconds. So we're good there. So t equals 5, V equals 10. So 10 is A plus B e to the minus a half t. So that is 2.5, which isn't a particularly nice set of equations. But we've got equation 1, equation 2. We have a pair of linear simultaneous equations. Probably the easiest thing to do is to subtract. So if I do 1 minus 2, I get 46. The a disappears, and I get b 1 minus e to the negative 2.5. And therefore b is 46 divided by 1 minus e to the minus 2.5. And if I plug that in, we want the numbers to 3 significant figures, although we might want to keep a bit more than that. So 46 divided by 1 minus e, which is shift ln, to the negative 2.5. Okay, that is 50.11357. We need to then go back and work out A. Well, equation 1 tells us that A is 56 minus B. Now I've still got it on my calculator. So 56 minus answer is 5.8886427. Now we only want, I've written more accurate answers. So to 3SF, so A is 5.89 and B is 50.1 to 3SF. Now, sorry, that is not actually the answer to the question, because always go back and reread it. Find a complete equation for the model. So the model is V is A, which is 5.89 plus 50.1 e to the minus 0.5t. So that is my answer to the question. Okay. Right, given that the skydiver eventually descends to the ground at a constant speed of 6, evaluate the model. So that's referring to this thing I did up here, right? So the asymptotic value is the value of A. So all we need to say here is, according to the model, V decreases towards 5.89 meters per second, which is very close, sorry about my writing, to 6. Therefore, the model seems accurate. Okay, that's all you have to say, right? Because you're only commenting on the one piece of data that they've given us. They haven't given us anything else. So that's the only thing we can talk about. So it does, the velocity does reduce towards this value of 5.89, which is pretty close to 6. Okay, so we say that's a good model. I know it's not perfect, but it's good enough. Okay, so that is question 9.